Morning, I'm Rory and welcome back to Sawyer Academy. In today's video we are talking taper or log taper compensation. In the last video we talked about log orientation, so now let's assume that we have that and our log is now dogged and secured in that orientation. The next factor to consider before sawing is the difference in the large and small end diameter of the log. Like I said last time, in commercial sawmills, it generally doesn't matter at which end the large and small end is, but we always need to compensate for the difference in the two. What taper really means is better aligning face 1 and face 3 with the saw line. Smaller logs with no or negligible difference in taper don't require taper compensation. But as logs get larger, generally the bigger the difference between the small end and the large end you'll see. For our purposes today, taper will only be applied to faces that we will be not referencing a flat side of an opposite face. So in a standard rotation, we will be applying a taper to face 1 and face 3. We will not be applying a taper to face 2 or face 4. For now, let's just consider the taper on face 1 of a log. Taper or taper compensation is expressed as a percentage of the difference between the large end and the small end diameter of the log. This percentage is set up in advance and may change with the species of log we're sawing, but in general, you will always be using the same taper percentage all the time, every time. So with that, you can pick a taper percentage anywhere from 0% to 100%. For me, and probably most applications, a 50% taper will be best for an all-around compensation to use every time. The three main choices you're going to have are 0%, 50%, and 100%. Now, what does this really mean? So in this example, we have a top-down view of 3 identical logs, all referencing the saw line. Our large diameter is on the left, and the small diameter is on the right. And in this example, let's call our large diameter 36 inches, and our small diameter as 30 inches. How taper is applied in a commercial sawmill is our carriages have 3 or 4 bunks. All of these bunks can move together and they can all move independently. So if we look at these examples, these blue boxes represent, again, a top-down view of our carriage bunks. So in our first example of a 0% taper, our first face of our log is very skewed to the saw line, which is going to result in several short boards off the start. But that would give, when we rotate 180 degrees to face 2, on the back side, it would give us a very good recovery with full length boards. And then conversely, at 100% taper, our face 1 of the log will have a very good opening face. It'll be full length of the log. But when we rotate 180 degrees to face 2, on face 2, then we're going to have short boards that are not the full length of the log. So basically that means you'll get good recovery on face 1, but bad recovery on face 2, bad recovery on face 1, good recovery on face 2. For me, the sweet spot that works well in most or all applications is a 50% taper. That'll give me good recovery on face 1 and face 2 with more medium length boards coming off of each face. A 50% taper can also be thought as aligning the pith of the log parallel to the saw line. Since taper is expressed as a percentage of the difference between the large and small diameter of the log, in this example, the difference between the large and small end is 6 inches. So with 100% taper, we will be applying a 6-inch taper. At a 50% taper, we'll be applying a 3-inch taper. And with a 0% taper, we'll be applying a 0-inch taper. And how that is applied specifically is that in, let's say, 100%, this 4th bunk will move the entire 6 inches, or bunk number 1 could move back 6 inches. On a 50% taper, same thing, bunk 4 could move forward 3 inches, bunk 1 could move back 3 inches, or bunk 1 could move back 1.5 inches, and bunk 4 could come forward 1.5 inches. Now, if you were sawing this log on a portable sawmill, let's say we're looking at this from the side now, we'll be talking about a horizontal portable band sawmill. So our saw line is now on top. The way we would compensate this log for that sawmill would be to jack up the front end of this log. So whether that's with a jack that's built into your sawmill or something you've added, or what I do is I have shims, and I put shims under the log to raise the small end up. And then from that, if you wanted, so in this case, if you wanted a 50% taper, you would need to put a 3-inch shim or use your jack to raise the front end 3 inches. If you wanted 100% taper, you would need to jack the front end of this log up 6 inches. Again, that would give you at 100% really good recovery off this first face, but poor recovery off your bottom face. If you didn't compensate on a portable sawmill at all, you'd be left with a 0% taper. So this face of the log would be on the bed of the mill, and the saw line would come down and it would give you a 0% taper. Once face 1 is cut and you're on to face 2, now you have a flat side that's either referencing your bunks or the bed of your portable sawmill. So on face 2 and face 4, when we're referencing that flat side, we do not want to put a taper on. If you were to apply a taper to face 2 or face 4, referencing a flat side, all of your lumber, well, your entire cant would come out tapered. As well, every board out of that cant would also be tapered on the width for the entire length. In my career, I've only really ever used a 50% taper. I've never had the situation where I needed to use a 0% or 100% or anywhere in between. The only real application I can think of that you would want to use 100% or 0% is if you cut logs yourself. If you had trees growing on your own property and you noticed that all of the limbs grew on the, let's say, the south side, the north side of the log had no limbs up the entire face of it. Limbs and knots generally correlate to nicer, select, higher grade lumber. That would be a situation where of that particular log that you would want to get the best recovery or the highest grade lumber off that side. So let's say of this log that's 36 and 30 inches, and let's say it's approximately 16 feet long. Off this face, we had a bunch of limbs, a bunch of knots, gnarls. We can see that that face isn't very nice, but this opposite face has maybe very few knots or very few limbs and no gnarls. What we can do with that, if this is going to be our good face, we're going to orientate that, as long as it's not too crazy, we're going to orientate that to our face 1, the nicest face to start with, and we're going to apply, or we could apply, a 100% taper. Because what does 100% taper get us? That gives us very good recovery, full length boards off of face 1, and poor recovery off the opposite face. So in this situation, we don't really care what this grade is. If this is going to be number 3 or number 4, who cares? If this face is all select and number 1, we want the most out of that. The hard part in commercial sawmills is when the logs come off the debarker, it's hard to tell where the limbs are without stopping to really look at a log. And in a high production application, you don't really have the time to sit there and rotate and look at the log. We load our log and we cut it in a matter of seconds. So that's why I always stick to a 50% taper across the board. It's very uncommon also to have a log in this situation with one side good and one side bad. It does happen, I've seen it, but it's never enough that I would stop and change my computer over to a different taper compensation for just that one log. One last thing that I want to touch on is taper in a scrag sawmill. In a scrag sawmill, you will rotate your logs, or you can rotate your logs. You won't apply any taper. Why that is the setup of a scrag mill, or the theory behind a scrag mill, is the logs, this is the end view looking down the length of the saw line. The logs are loaded onto either a sharp chain or a V-flight chain. As well, they're held from the top with press rollers, and those press rollers sometimes are hourglass shaped. If we look down the length of the saw line in a scrag mill, what we'll see is that the sharp chain and press rolls hold the log such that the pith of the log, the very center of the log, is parallel with the saw line. And from our previous examples, we know that when the pith of the log is parallel with our saw line, that gives us a 50% taper. So why scrag mills don't apply a taper is that scrag mills always, every time, apply a 50% taper because of the way the chains and the press rolls hold the log centered in that saw line. But that's all I have for taper and log taper compensation. If I've missed anything, or if you use a different way to taper, or you use a specific taper percentage, leave it down in the comments down below. But that's it. Thanks for watching, and I'll see you next time.